We often picture the caveman as a grunting wanderer draped in a dirty pelt, surviving a harsh world through a string of lucky accidents. In reality, surviving the last glacial maximum required high-level science. These populations were pioneering material science, thermodynamics, and mechanical engineering. They worked without metal or plastic, but they engineered foundational systems that modern survival still relies on. The aerodynamics keeping a modern helicopter in the sky, and the polymer chemistry used to synthesize industrial superglue were first mastered tens of thousands of years ago. Analyzing this era reveals the foundational engineering boom that wrote the source code for our modern world. 50,000 years ago, humans began synthesizing entirely new substances. They produced birch tar mastic, the world's first synthetic polymer adhesive. This diagram tracks the manufacturing process. Creating this tar required a multi-hour, oxygen-depleted thermal bake of birch bark. It demanded precise temperature control to prevent the bark from burning to ash, instead coaxing out a sticky, waterproof resin. That oxygen-depleted chemical synthesis is the direct origin of the heavy-duty construction epoxies and waterproof marine sealants used in industry today. They also applied thermal manipulation to stone. 72,000 years ago, early engineers learned that burying silcrete rock under steady, low-oxygen campfires restructured the internal crystalline matrix of the stone, making it significantly sharper and easier to flake. Today, we use this exact process of heating a material to alter its structural properties to manufacture structural steel and industrial ceramics. By deliberately manipulating molecular structures through thermal and chemical science, these ancient populations established the framework for all modern synthetic manufacturing. This deep-time engineering extended to invisible physical forces. The boomerang, for instance, functions as the world's first human-engineered airfoil. This cross-section shows the asymmetrical geometry, a flat bottom and curved top. Thrown, it creates a pressure differential, generating aerodynamic lift. This exact profile is the physics foundation for the lift of every modern airplane wing and wind turbine. Ancient hunters also built kinetic force multipliers like the atlatl. By artificially extending the human arm, the atlatl acts as a Class 1 lever to radically increase projectile velocity. To secure marine prey, they designed the toggle harpoon. This device uses a detachable point that rotates 90 degrees inside a target, anchoring it sideways under line tension. The kinetic behavior of that harpoon remains entirely unchanged in modern hollow wall anchors and toggle bolts, proving these ancient kinetic solutions remain the most efficient way to manipulate force. Around 40,000 years ago, toolmakers abandoned random rock smashing in favor of the punch-flaking core system, using bone punches on standardized cylindrical stones. This method allowed them to peel off dozens of uniform, razor-sharp blades in minutes, functioning on the logic of high-speed repeatability, just like a modern industrial stamping die. They used those standardized blades to engineer modular weapons. By carving grooves into a bone point, they could glue multiple tiny stone microblades into the slots using tar. This modularity created incredible efficiency. If a single blade chipped, they simply heated the tar, popped out the broken insert, and snapped a fresh one in. This design philosophy of using cheap, replaceable cutting edges is the same logic driving modern utility knives and industrial CNC milling machines. The mechanical continuum connecting us to the Paleolithic is everywhere. The structural twisting of multiply fiber cordage, invented over 50,000 years ago, utilizes the same tensile physics keeping modern rock climbers alive on a cliff face. The matched stone sets used to grind pigment 100,000 years ago operate on the identical friction-based particle reduction mechanics used in modern pharmaceutical compounding. The human brain has not evolved new capacity over the last 50 millennia. An ancient toolmaker possessed the same neurological hardware and capacity for genius as a modern aerospace engineer. The primary difference between their era and ours is the raw material available. We traded bone, birch tar, and stone for carbon fiber, steel, and industrial plastics. We are running version 10,000 of the mechanical software written at the dawn of our species. Every time we use superglue or a toggle bolt, we are directly interacting with Stone Age brilliance. Ancient people were master engineers. Subscribe to Ancient Archive Blueprints as we explore more master designs from the past.